Example just showed us that it's difficult to say that a series diverges in general. So luckily, there's something that'll help us out. So to start, we're going to notice that don't do that. The following statement says, if the series A sub n is convergent, then the limit of A sub n is 0. It doesn't seem that helpful because this statement is just saying if you already knew that your series converges, then you know that the limit of your terms is 0. Yeah, so you have to be very, very careful with this, and I'm going to write a big note right here because every time I go over this theorem, it's used incorrectly. So I want to say this does not say if the limit is 0, then A sub n converges. See the harmonic series. So if you look at the harmonic series, it's 1 over n. If I look at the limit of 1 over n, what's that limit going to be? Hold on. The limit of 1 over n, as n goes to infinity, that's 0. But the series 1 over n diverges. So just because you get 0 for the limit of your terms doesn't mean that your series converges. Okay? So be very careful. Whenever you get a limit of 0 for your terms, you don't know. Could converge, could diverge. But there is a silver lining in this, and the silver lining is what's called the divergence test, which says if you get anything other than 0, so the limit of A sub n does not exist, or the limit's not 0, then the series A sub n is divergent. So if you calculate a limit, get anything other than 0, you automatically know that it diverges by this test. So let's put this to use. Let's do a problem. So example, show the series n equals 1 to infinity n squared over 5n squared plus 4 diverges. So let's calculate the limit of the terms A sub n in my series. N squared over 5n squared plus 4. We've seen this limit before. What's that limit equal to? Squared.
1/5.
1/5, right? We've gone over this limit a few times, 1/5. Is that 0? No, this is not 0. Anytime you get anything other than 0 back, the divergence test tells you that that series converges. So you would say this series diverges by the divergence test. Okay? So whenever you're saying converges and diverges, you should say why, what method you're using to determine that. So here I'm using the divergence test. Okay? So again, anytime you get anything other than 0 for the limit, you're going to say that it diverges by the divergence test. Okay?